So think about it as when you're here, like when you're standing, when you're not on a plane, the earth attracts you with more force. But when you're on a plane, you're further away. You're further away, so it's different. The gravity is not as strong as it should be, or think about it as being in space. There's no gravity attracting you towards the earth because we're too far away from it. Which of this one is the most influential on the kinetic energy of an object in motion? Mass, velocity, gravity, or height? So, does anyone know the formula for kinetic energy? Okay, E equals 1/2 mv squared. So, taking that into account, we have in the formula both mass and velocity. Which of those two is the most influential? Velocity, great, why? Why is it mass? Okay. So it's more velocity. So velocity because it is squared. So are we with that one? Yeah. Great. It is indeed velocity. Because if you have a higher velocity and you also square it, you're going to have even a bigger number. So velocity is more influential than mass when it comes to kinetic energy. Now, for question 18, we also have another problem. Mike's little sister, Catherine, can reach anything in the house within 1 meter of the ground. Catherine often steals Mike's phone, which weighs 3 kilograms. In order to stop her, he decided to give his phone some amount of GPE. So what has to be the lowest amount of GPE necessary for his phone to be out of reach for her sister? What formula are we going to use for this one? Sorry? GPE. So I want to see all of you with your calculators, and then you tell me which one is it. Yes? C? Does anyone else agree? C? Yes, great. What formula did you guys use? And GPE, but what's the formula?
Times y.
So MGY.
Yep.
Negative MGY. Right. So C. So remember when we said, pretty sure it was the second study review? Or the first one, I can't remember. GPE is, it's related to position. So when we have GPE, we relate it to the distance from the ground, and then when we have KE, it's about velocity. Now this is some of the new content that we had this couple classes. True or false? The periodic table of elements was originally based on properties of the element which correlate to atomic weights. Sorry. True or false? I mean, even if you try saying it, you have a 50-50 chance of having it right. Okay. Atomic number now? Yeah. So it is true? Yes, great. Let's see. So yeah, it is true. I'm pretty sure that in a while we have a question about how they organize them now. Now let's go to work. Which of this one isn't an acceptable unit for work? D? Does anyone know the formula for weight? For work, sorry? F delta X. So F delta X. So we have mass, we have acceleration, and then we have X, which is also a unit of distance. The thing is, pounds and feet can actually be a unit of work if you, instead of using kilograms, use pounds, and instead of using meters, use feet. That's not what we normally do. We go by kilograms, meters per second, but that's an acceptable unit. So the one that's not acceptable is P over T.
What was the formula for work?
F delta X.
So if you want to write it down, the formula for work is F delta X. Once a base elevation has been defined, for example, sea level, obtaining height above that level requires what? Electricity, acceleration, gravity, or work?
Work.
Work? Great. Why?
Wait, I heard someone else say it.
Do you have an answer of why? Anyone? Can it be electricity? Do you need electricity to change your height? No. Do you need acceleration to change your height?
No.
So he says that it goes back to GPE. It's GPE is a type of work, and because of that, you need work. So great. Now we're going back to work. We continue talking about work. It says you lift a 4.5 kilograms keg from floor level to 2.5 meters above the floor. How many joules of work are required for you to perform? We already said that the formula for work was F delta X. Now, how do we find out the force for this one? Mass time velocity, grade Y. Why? And what's the velocity?
Find force.
How?
F equals ma, which is the 4.5, just give it times the 9.8 constant.
So you're using, for acceleration, you're using gravity.
Yeah.
Okay, so what type of force is that one? The mass times gravity. Sorry? It's a downforce, okay, but what else? It has another name as well. No. there's a particular force that's called something, and the formula is mass times gravity.
Oh, weight force.
Weight force, great. So for this problem, you're using the weight. So the force, m times g, which is the same, but it has a name. So if you were to ask to calculate weight, you have to do mass times gravity. So you have that. Now, what's the answer? 110.25. Can anyone else verify that? 110.25? Yes? Yes? Great. So here you have it again. Work equals F times delta X, or D in this case also. And you use mass times gravity times the distance from the floor, and you get 110.25 joules of work. Now, which one of this is not a form of energy? Is it electric? Is it mechanical? Is it nuclear? Is it radiant? Or is it none of the above? D, radiant? None of the above? You say A? So none of the above. They are all different types of energy. Even radiant, even though I'm pretty sure we haven't heard of that one, is a type of energy. True or false? Any form of energy can be converted into another form. Anyone else have any thoughts about that? Is it true? Is it false? It's true? You say it's true? It's false? You say true? Just, sorry? It is true. You can convert energy. You do. You can convert it into any other form of energy. I'm pretty sure there was a phrase that was like, you can destroy energy, but you can transform it. I'm not sure if that was a phrase, but. The rate of doing work is power. Great, why? Because it's none of the others. Huh? Okay. Great. So it is indeed power. We know that when you calculate work, you're not calculating the acceleration, the velocity, or the momentum. So that's also a way to eliminate all the others. And it is because of what you say, it is power. Now let's talk again about kinetic energy. When is kinetic energy equal to 0? See? The object is at y max. That's when you have the most GPE, right? Okay? So I see that most of you agree. And I agree as well. Zachary sprints up 10 meters of stairs in 4.6 seconds. Sydney sprints up a separate 10-meter staircase in 5 seconds. Who has done more work if their masses are the same? I have a typo right there. Sorry? A? Okay. Let's go back to the formula again. We said that W work equals F times delta X. We know that delta X is the same. We know that their masses are the same. Neither. Because they're both the same. Because if we go back, the gravity was the same, the mass was the same, and the distance was the same. So C, neither of them did the same amount of work. Which one is the analog of force? Is it torque, rotational inertia, angular velocity, or rotational momentum? A, torque. Does anyone else agree with that? Yes, everyone agrees. Great. True or false? Leverage depends on the force you exert and the speed at which it is applied. True or false? False? Great. Why? Okay, so it doesn't involve speed. Depends on the force and where you're applying the force. Great, so it is false. Now let's talk about water, H2O. At a temperature of 272 Kelvin, in what state of matter is any grams of H2O? Is it liquid, is it solid, or is it gas? Liquid. Liquid? Yeah? Yes? Sorry? So it melts at 273. So at 272, it should be liquid. Solid, sorry. I actually agree with that. Barely, but it is solid at the end. So at 273, it's where you change from solid to liquid. And when do you change from liquid to gas? Close, but not enough. 373. So 273, it's easy to remember. It's 100 degrees of difference. At 273, you have melting point when water is transformed, H2O is transformed from ice to water. And then at 373, water goes from liquid, H2O goes from liquid to gas. How many calories are required to heat 1 gram block of ice by 1 Kelvin? How many? 0.5? 1 calorie, great, why? Does anyone know the definition of a calorie? So yeah, 1 calorie raises. So that's actually the definition of calories. Now, this one goes back to the heat. Yes. Sorry? With what?
The last question, isn't it calorie with a capital C? No,
The-
that's food, isn't it? The capital C is regarding to calories in food, not calories in heating up grams.
That's a great question. Which one is it? Is it calories with a capital C
Lower
for
C.
food? For food,
Oh, food is capital.
capital, and then for the other ones, lower. Especially in those type of problems, they let you know that you're also talking about food calories. So that's also something to make sure that if you have doubts, it probably is in the problem. So, how many calories must be removed in order to convert 1 gram of liquid water at 273 into a block of ice at also 273? So we're not changing temperatures, we are only changing state. And it's 1 gram of liquid water. Think ahead, think about the heat melt heat problems.
Zero. It's the same, right?
Yes. Is the 80 grade Y? That's the latent heat? What? Sorry? Okay, so it's 80. But if you had 2 grams? 160? Great. So, without changing your temperature, to go from liquid to ice, you need 80 calories. You need to remove 80 calories. That's also the number for latent heat of fusion. Which of the following is not a mode of heat transport? Is it conduction, convection, convulsion, or radiation? Convulsion. I see that most of you agreed, and I do too. For those of you who came in late, please make sure that you fill out the study union evaluation and that you leave them before you go. So they are around somewhere. You don't have to fill them now, but make sure that you do that. And if you don't have one before leaving, you can come here and just grab one. Bless you. So, converting 6 grams of water from 243 Kelvin into a block of ice at melting point requires the loss of how many calories? And how are we going to calculate that one? Sorry?
Would you do 6 times 80 from the last problem, or is this something different?
That's a great question. Does anyone know what to do in this type of problems?
It's the Q1, Q2, Q3 thing.
What's the formula for Q? Does anyone have the formula?
Mass times, latent heat, or whatever.
Which one?
Oh, MC delta T.
MC delta T. So mass,
Capital T.
C, and delta T. So, for mass, we're going to use 6 grams. For C, what are we going to use?
What you are heating or melting, which is water. So it's 1.
Specific heat.
1.5. No, that's ice. Yeah, just 1.
Just 1? Okay, and for delta T?
You gotta do 273 minus
30? You have to get it to the melting point, which we already said is 273. So from 243 to 273, how many? 30?
Yeah.
So 6 times 1 times 30. So how many calories? 180. I actually have the answer wrong. So sorry about that, but you are right. It is not 660, it is 180. So 180 calories. Great. Yes. Is it 0.5 or 1? 1. And what are we working with? We're working with ice. So it should be what? So it is 1 or 0.5? How can we figure out if it's 0.5 or 1, besides asking me? Yes? So if it's ice, it is not telling you that it's changing. It's just telling you that it is ice. So is it 1 or 0.5? 0.5? Great. So it is 0.5 times 6 times 30. And the answer is 90. So it is 0.5. How else can we figure out? Asking Google.
Wouldn't it be worded that you wanted to start out as a block of ice to water instead of saying converting 6 grams of water from... Oh, never mind. I get it.
You get it, agree. Sorry, we good with yes? It is a solid. The thing is that you're not changing states. You're just taking it into the melting point, but without changing the state. So it's not telling you like it changed from... It's not asking you to transform it to liquid, just to get it to 73. You just do Q1. If it told you it changed from liquid, from solid to liquid, then you will have to calculate the Q2. And if it even goes further than 273, you will have to calculate Q3 as well. Great? Awesome. Is it 90? The previous question, was it 90?
Yeah.
Yeah, great. Now, convert 400 grams of ice at temperature equals 268 to liquid. Now it is telling you to go from solid to liquid. So you're going past the 273 and all the way to 288. So how many Qs do we have to calculate? 3. So Q1 goes from 268 to where? 273. Q2? Do we care about the temperature? No? You just do what? Latent heat. Latent heat times the grams. So 400 times what? Times 80. And then Q3 from where to where? 273. So from 273 to 288. So calculate it, and once you're done with that, raise your hand, and we'll see if we got the same answer. She got 39,000. Yes? 2? Yes? Yes? Great. Is anyone having trouble? Yes, you got the same? You? Okay, so let's go step by step. For Q1, what did you guys do? Like, we said that it was Q equals MC delta T.
Okay, so Q1 should be MC delta T, which is the mass, 400 times the specific heat of ice, which is 0.5, times 273 minus initial temperature, which is 5. So for Q1 should be 1,000. Q2 is going to be 400 times 80, which is the latent heat of fusion, which is 3,200. And then Q3 should be MC delta T again, which is 400 times the specific heat of water, which is 1 times, the final temperature minus 273, which is going to be, 15, and then equals 6,000 total.
6,000 plus 1,000 plus 32,000 is 39,000.
So you got them all together. Great, yeah? Is everyone good with this one? Great. So yes, I got the same answer. Now let's talk about waves. Is anyone still working on the problem? Or can we, okay, great. Let's talk about waves. Waves transport blank and blank across a space-time. What do they transport? Energy and motion?
Energy and momentum.
Great. Where did you get that from?
I wrote it in my notes.
Great. So check your notes, and there's the answer too. If for some reason you still live here and you still have a few questions, check out your notes, check out YouTube lectures. Every question that's here was taken from that, so you will find it. And if you have your notes, then you can also go back to the YouTube lecture and rewatch it to understand more the concepts. So, spring force is a infinite range force, diminishing force, restoring force, or imbalanced force. Restoring. So think about, I don't know how are they called, the things that you play with. There are springs. That, slinky? Think about it, when you pull it out, it goes back, and then you pull it out, you extend it, then it compresses, and then goes back to its normal state. So it restores back to the equilibrium point. So it's a restoring force. True or false? Two objects are at thermal equilibrium when they have the same temperature. True. What is the unit of charge? Sorry? You don't know if that's right? Yes? A coulomb? It is a coulomb. We didn't talk much about charges, but when you measure a charge, it is measured in coulomb. I'm pretty sure you had to know this for one of the homeworks. For a neutral atom, the atomic number is equal to A, number of protons in the nucleus, B, number of neutrons in nucleus, or C, number of electrons in the nucleus, or D, A and C. B, D, A, I mean, it is D. Sorry? number of protons in the nucleus. So these are the types of things that we need to memorize. So the atomic number is the number of protons that there are in the nucleus. I have a typo here again. According to de Broglie, well no, I don't. To de Broglie, how can an electron be treated? As a wave, as a nucleus, as gravity, or none of the above? Wave. So we've heard a lot about that in class. So most of you went, great. I'm not sure if we got all of this class, but which one is not true of noble gases? A, they are located on the far right of the periodic table. B, they do not combine with other elements. C, they are monatomic or none of the above. Sorry?
See?
You say C, someone said B, someone says D. So for this one, they sometimes, but really rarely combine with other elements. So it could be C, but it's not normal, yes. That's a great question that we should Google.
We won't have Google on the test.
But you have it right now and you're studying. I wouldn't care too much about that. We actually didn't saw that in class. It's just that I had to finish the exam review before we had class, and I thought we were going to talk about that, but we didn't.
Consistent one atom, right? Like contact this.
So, going back to atoms, the first energy level surrounding an atom is known as, you figure it out? What it's monatomic.
Consisting of one atom.
Consisting of one atom.
What it is.
Okay, now, the first level surrounding an atom is known as ground level, ground state level. Now let's talk about history a little bit. Who created the first table of elements? Was it Aristotle, Planck, Mendeleev, Dr. Mendeleev, or Einstein? Dr. Mendeleev. Ooh, sorry. My bad. So see, Dr. Mendeleev. For the exam, remember also to study what each scientific contributed with. All of the ones that we have seen throughout the class, make sure that you know what they did and how they contributed to physics. Now, the first level surrounding an atom holds how many electrons? Two? Great. It is, 2. True or false? Heat always flows from cooler objects to warmer objects. That's a pretty easy one. Now, after the ground state level, each successive level of an atom is known as what? There's a typo also in the...
Is that sublevel, like sublevel 2, sublevel 3, or N2, like
This is the first excited state, the second excited, and the third excited state. I don't know, the typo was in the next. So pretty easy to remember. We have ground state, first excited, second excited, and so on. How many atoms does the second level hold? 8, right. What is the latent heat of fusion? Is it the amount of energy needed to break bonds in gaseous state? The amount of energy needed to break bonds in solid state, the energy needed to increase the temperature of the object, or none of the above? Sorry? B? When do we use latent heat of fusion? For water, for example, the problems that we were doing before.
Yeah, that's when you go from a solid to a liquid. Or any state.
So it is B.
No, because isn't the other one when you're going from a liquid to a gas, the latent heat of vaporization or vaporization?
So we have two. We have the fusion, which is what's the number for water? 80? So in latent heat, we are not moving from temperature. It is only the energy required to break those bonds in solid state to make it to liquid state.
Right.
So it is B. Pretty simple one. True or false? Electrons attract electrons and protons attract protons. False. Electrons attract what? Protons. So opposites attract and same sign? Repel? Great. Now remember we talked about this before. How is the modern periodic table organized? Is it by the year each element was discovered, by the number of electrons, by the atomic number, or by the atomic mass? By the atomic number? Yes. Now, we also talked about this before, about weight. What is the weight of a 40-kilogram person? How can we figure it out? Yes? Sorry? 51? Sure. C, by the atomic number. Okay, so how can we calculate weight? Sorry? Mass times gravity. So it is m times g, which is 392. Anyone else agree this side? Yes? Anyone has something different? Great. So it's the same. Are weight and mass the same? Are weight and mass the same, or are they different? So weight is what? Yeah, but... Okay, so if it's newtons, it's what? What do we measure in newtons? Force. So weight is a force, whereas mass is just a quantity that carries inertia. Right? This one. True or false? Velocity is the same as acceleration, and they are both measured in meters per second. Great. Why? The acceleration also entails direction. Great. What else? Okay, great. What else?
Like, that was velocity or acceleration?
That's acceleration. So velocity, we measured it in what? And acceleration? Meters per second square. Yes.
But yeah, acceleration must be gravity, right?
Acceleration can also be gravity, or gravity is a type of acceleration. And remember, one of the first questions we said that acceleration was a change in velocity as well. So we have acceleration, change in velocity, change in direction, and measured meters per second square. So if you're given in a problem, velocity, it's not the same as acceleration. Now, part of the concepts that we still had to do with one of the concepts that we got was quantum theory of hydrogen. Which one is correct for the quantum theory of hydrogen? Only a few orbital levels are allowed. The electron only lives at certain specific altitudes and no others. Each altitude has a set EPE. As an electron drops lower to a lower EPE orbit, it emits a photon with missing energy, or all of the above. If you have your notes with you, it's a great time to look for that. Yes? All of the above. So yes, all of them are part of the quantum theory of hydrogen. Now, what is the net direction of the rightmost electron in this set of protons and electrons? Is it going to the right or is it going to the left? So if we look at it, let me see if I can show. Okay, you can see my cursor, but we're talking about the electron that's at the rightmost electron, so it's the one that is next. It's before the two positive signs, and it has two positive signs to the right and two positive signs to the left. So is it So is that electron being attracted by the other electrons, or is it being repelled from those?
Wait, we're looking at the very last proton on the right, correct?
Electron. Rightmost electron. The one that has to the right protons and to the left electrons.
Right, it's going to be repelled and attracted.
Great. So you have protons at the right, which are going to attract it, and then you also have some electrons at the left that are going to repel. So you end up going to the right. Now, what is the net direction of the, is it called asterisk? Yes? If it has the same two ones, it has proton, electron, proton, and then to the other side, it also has proton, electron, proton. So it has the same forces to the right and to the left, so it is going nowhere. So 57, true or false? Conservation of momentum states that the total momentum of a group of interacting objects remains the same in the absence of external forces. Sorry, I didn't hear. True? So yes, that's what conservation of momentum means. Think about it about the boxcars. When you start, you you started having a momentum of each of the cars, and then you equal that to the end, to the final momentum, and that way you could figure out the final velocity of those boxcars. What produces tides in the ocean? Is it the moon gravitational movement, sun gravitational movement, all of the above, or none of the above? A? A. Now we have a problem. We have two users, user A and user B. User A has a mass of 12 kilograms. User B has a mass of 24 kilograms. User A is headed east down a path with constant velocity of 14 meters per second, while user B is headed west down the same path with a velocity of 7 meters per second. Post-collision, in what direction are they moving and with what momentum? You have to calculate what? Remember, conservation of momentum? That's, I mean, you're missing part of it. Because initial, you have two moments. You have the initial in which one car, user A, is moving and user B is also moving. But they're both part of the initial conditions. Whereas for the final, it's when they both collide. So how can you calculate the initial momentum? And what's the formula for momentum again? We said it earlier. Mass times velocity, you two said the same, so P equals mv, mass times velocity. Sorry?
That's the direction it's going to move. So say, I didn't calculate that, so say 12.14 is larger than the 24 times 7, it would be going to the right.
No, they're both the same.
They're both the same, so you have the same for user A and user B?
I'm getting the same momentum for each one.
So what would be if you have the same, are they going the same direction? They are going opposite. So to figure out the momentum, the initial momentum, what do you do? Because you have already the momentum for user A and for user B. What do you have to do with those two? Since they are going in opposite directions. Subtract? Okay, and what would you get? If you said they are the same? So what do you get if you subtract them? Zero. So that's the initial momentum. And what would be the final momentum? If we said that, if we go back to conservation of momentum, if we say that it remains the same, didn't we say that the initial momentum was the same as the final?
Yeah.
So wouldn't it be 0 and 0?
Yeah.
So they're not going anywhere?
Yeah, once they hit, they just stop.
So yes, they are not going anywhere. If you had different numbers, then the situation will be different and the problem will be different. But yes. Now, let's go back to this table, the GP and KE formula table. Here I added a few things that not in the original table that but we can also calculate, and that you also need to calculate KE and GPE. So based on that, just without calculating anything, what else can we know about it? Yes? Where? On the first one? So the first one, K is 0 because we're at y equals max. What about, and also they're telling you that the velocity is 0. What about the total mechanical energy? So at the highest level, even though we don't know the height, which one is, what's?
Gravitational would be.
No, the mechanical energy. Yeah, at the highest point. Mechanical energy, so E. It's going to be the same as GPE. So for the first one, I have the whole table completed, so I'm not going to go through that. So you're saying that KE is 0, and that E is the same as GPE, so 61,740 joules. What about the height for that one? How can we calculate it?
We're using the GPE formula.
Okay, so for that one we have the mass. What's the formula, sorry, for that one? MGY. So we have GPE, we have mass, we have G. We have to solve for Y, right? So calculate the Y, where the GPE is 61,740. And please let me know what you get. MGY, it's the formula. GPE equals MGY. Sorry? 150. Does anyone got 152? Someone has something different? 150? 150? Great. How can we calculate? In that one, we are missing the time. How else can we calculate the time for that one? I mean, we are starting, so we haven't even dropped anything. What's the time? Would be 0? Yes. So you're starting, you still don't have any time, you have 0. What about at height 0? What else do we know about that? What about the KE and the GP over there? Sorry? GPE will be 0, and what about KE?
The highest, which is the 61,740.
Great. So I'm going to go ahead. This is the finished table. But you can't see the red and the black ones anyway. So, what about the time? How can we calculate the time? Sorry? Great, which one? We used it before, the distance formula. Does anyone remember the distance formula? Yes. Great. So distance equals 1/2 gt squared. We know gravity. And we also have the height at the left side. So this table has a lot of things. I just want us to make sure that we have everything to complete it. We already said that we're going to use the distance equals 1/2 gt squared. What other formulas are we using to complete it? Yes?
Well, time is 1/2 gt squared,
Kinetic energy is 1/2 mv squared.
GPE is the negative mgy.
GP negative mgy.
And then energy is kinetic energy, total energy is kinetic energy plus gravitational potential energy.
So total mechanical energy is kinetic energy plus GPE. And what is also important to note about mechanical energy? It stays the same. So if you go back to the table, you see the right column, it is always the same. So GPE and KE, when you add them together, you always have to have the same number. What about velocity? How can we figure out velocity in these problems? From which formula? Kinetic energy. So again, which one is the formula for kinetic energy? 1/2 mv squared. So you solve for V, because you will have already figured out kinetic energy. You have the mass, you solve for V. Any questions about this one? I know it's kind of, yes. For time. What formula do we use for time?
1/2 gt squared.
1/2 gt squared. Distance equals 1/2 gt squared. Yes?
How did you find out height?
Great question. How can we figure out height? With which formula? Yes? GPE, mgy, so GPE equals negative mgy. And of those letters, which one is height? Y. Great. Any questions about this one? Any doubts? Great. Now we're going to match a few concepts. We have constructive, destructive, beat, translational motion, rotational motion, and combination motion. Overall modulation of sound from the mixing of two different frequencies. C? Beats? Yes? So 1, C, beats. 2, peaks aligned with thorough result in this type of interference. The
Peaks aligned with troughs.
That's destructive.
destructive. So when you get those two, do you get a big wave, a big thorough, or nothing? Nothing. Great. What about when you have, so 2 is destructive, letter B. What about the third one? Peaks aligned with peaks result in this type of interference. Constructive. So you get big what in that one? What's the result of a peak with a peak? A bigger wave. Great. Now, if you go from point A to point B on a straight line without spinning, what is that? Translational motion. If you rotate about a fixed point, rotational motion, great. And if you have the two of them, great. So here you've got them again. Sorry, I forget about that. Are we good with this one? Anyone still copying? Great. Now this one's pretty easy considering I didn't change anything. I didn't sort them out. So you have to name the following phase transitions. From liquid to solid, how is that called? Sorry? Freezing. So A, liquid to solid, freezing. 2, from liquid to gaseous, vaporization or vaporized. 3, solid to gaseous. Yes.
I forgot to change them.
I'm like, that's weird.
So yes, 1 with A, 2 with B, 3 with C,
Yes,
4 with D. So solid to liquid, it's melting. Gaseous to liquid is condensation. And gaseous to solid, deposition. So most of them are really common for us to use every day. So try to memorize the ones that are not common, like deposition or sublimation. And they are from solid to gaseous and gaseous to solid. So it's keeping the liquid part. So those are the most weird ones. I'm pretty sure this is, yes, the last one. So name each of the following wave states. Remember when we did this spring in class? If you were either with Caroline or Darian, we talked about this. The first one, how is it called? Fundamental state. What about the second one? First excited state. The third one? And the last one? Almost. Fourth harmonic. So you have the fundamental or ground state, which is called the first harmonic. So if you're measuring in harmonics, you start with the first one. If you're measuring in excited state, the first excited state is actually the second wave. And so on. So this is actually the end of this. I want to say a few things before we leave. First, make sure that you collect everything that you have with you. Please don't leave this. If you have any trash, there are trash cans. There's going to be people after this session, so we want them to get the room as clean as we got it. Second, exam again is on Saturday. Make sure you keep studying. If you're if you signed up for SSG, make sure that you go to that. Those are great tools. I'm pretty sure Dr. also has office hours on Wednesday. If you're still having questions, go there. That's a great tool. I'm sure most of you have already gone to office hours. Make sure that you're not only studying with this practice exam. Make sure that you're going over notes, classroom notes from over lectures. Anything, Twitter is a great way also. If you go to web courses, you're going to find the link to Twitter. Make sure that you are taking breaks, that you're eating, and that you're sleeping, because it is important. We need to survive after this. Make sure that you have Scantron, pencil, eraser, calculator, eye clicker, everything ready for your exam, that you know your exam time, your classroom. Make sure classroom section 1 and section 2 are going to be in different classrooms. Make sure you go to the right one. Make sure that you please give me if you came in late, there are the study union evaluation sheets. Please make sure that you bring them to the front, that you give them to me. And again, I wanted to thank you for having a great semester. I really hope you the best of lucks in the final and in any other final that you have. And I think other than that, if you have any questions, please make sure that you sort them out before the exam. And thank you, and have a good luck on the exam. Please make sure that you bring me the student